So I warned you there would be more integration by guessing. So we have to practice a little more, and how do we compensate when all the pieces don't line up exactly? That's what we're looking at today. For the most part, they're going to line up. There's just going to be small differences that we have to compensate for. It's not going to be a huge, amount of variables or anything like that. We're talking more numbers. How do we compensate there? So, if you had to guess, because that's what we're going to do, we're going to guess when we integrate the sine of 3t dt. What would you guess for the sine of 3t dt?
Would it be negative cosine of 3t dt?
Except not the dt?
Yeah.
So the integral of sine of something is negative cosine of something. Make sense? Just, get that all straightened out in your head. And so my guess, I'm going to use u here, is negative cosine of 3t. That's my guess. How do I check my guess?
Well, we take the derivative.
We take the derivative of it, right? So the derivative of u is du. The derivative of negative cosine of something. Sine of that something, right? Because the derivative of cosine of something is negative sine of something. So derivative of negative cosine of something is going to be negative, negative. So in other words, a positive sign. So the derivative of this negative cosine of something is sine of something times the derivative of something. What's the derivative of 3t? 3. And then we did this with respect to t, so we're going to say times dt. Now, the key is, does it all match?
Not yet.
Not yet. Good answer. Okay. So over here, in my original problem, I have a sine 3t. I have a sine 3t. In my original problem, I had a dt. What doesn't match?
The old 3.
I have a 3 that doesn't match. How do we compensate for a factor of 3?
About to say we divide by 3.
Okay, and dividing by 3, what is that as a number? That is the number 1 over 3. Okay, so in order to compensate for 3, we're going to need a 1/3 in our answer. So our guess was negative cosine of 3t. The only thing we were off by is a 1/3. So basically, we take our guess, and we have to include a 1/3 as a factor in front of it. So my answer here, instead of negative cosine of 3t, is going to be negative 1/3 cosine of 3t. And because it's an indefinite integral, plus c. By this point, you don't really have to check yourself again, in my opinion. But on this first one, you can kind of process through it that, we've got a negative 1/3. The derivative of cosine of something is that negative sine of something. But there's a negative here, so it makes it positive sign, times the derivative of 3t, which is 3. So times 3, but what's out here? 1/3, and 3 times 1/3 will cancel. Does that make sense? Maybe, maybe not.
Nothing too life-changing yet, but some of these other ones are a tad bit ugly.
Essentially, it's all really the same thing today. They're always going to be off by some constant that you have to compensate for.
Will we get to a point where it's more than a constant?
Not
And
usually.
it's like the homework is a lot harder though. They'll make it like more difficult.
Well, I have a feeling if you look at example, a few of them on the homework look like that. So do you think they would have foreshadowed it and like we were supposed to do something?
Possibly.
Because there were.
But I mean, it could have been going back to your original. I mean, this book does tons of foreshadowing. You guys see that all the time, right? But it could be that they were going back to the original integration by guessing, except they worked out perfectly. And maybe you just didn't realize it because you didn't remember it, or didn't recognize it. Because yeah, example 3, it looks more difficult, but in all honesty, it's the same type thing we just did. It really is. Abby?
I'm really sorry. I promise I was paying attention. But
No, you're fine.
Can you just walk me through the 3 again? I don't know. Didn't really grasp it.
So because when we take the derivative of this, we'd have to do the derivative of 3t, which is a times 3.
Yeah.
But if you look, so this right here is what my original problem should be.
Yeah.
But my original problem didn't have that factor of 3. And so what we have to do is we have to compensate for the 3. And basically, what do you multiply 3 by that will get it to cancel out? And so when you have the 3 to, I think it was said you divide by 3 to get to cancel out, which dividing by 3 is multiplying by 1 over 3. So basically multiplying by the reciprocal.
Oh, okay.
Okay? Does that help some?
Yeah.
Okay. Shall we try example 2 then? Okay. So we're going to integrate x squared times 3x to the third plus 4 raised to the fourth dx. And we're going to guess again. As we guess, what you kind of have to pinpoint is what's the overall main function here?
Something to the stuff.
The something to the fourth? And what is the integral of something to the fourth? Something to the fifth, yes? And I just go that basic. I don't throw other factors in. We'll get that here in a moment. So we're trying to integrate something to the fourth, my guess is going to be that something to the fifth. So I'm going to say, I'm using u, because that's typical what you use there. So it was 3x to the third plus 4 to the fourth. My guess is 3x to the third plus 4 raised to the fifth. And then what we have to do is we have to take the derivative of that and see, does it match the original problem? So, the derivative of u is just du. Derivative of something to the fifth. 5 out front, keeping the inside the same. What do we do to the power? Subtract 1. So now it's 5, 3x to the third plus 4 raised to the fourth times the derivative of the inside. What's the derivative of 3x to the third plus 4? 9x squared. And then once you're done, it's always times dx, because we're taking the derivative with respect to x. Okay. 3x to the third plus 4 to the fourth. Matches, yes? Dx matches. Do we have an x squared? Yeah, there's an x squared. It's kind of attached to something else, but that's all right. There's an x squared.
So we have a 5 and a 9.
So we have an extra 5. How do you compensate for an extra 5? You're going to have to multiply by 1/5. We also, it's right here, we have an extra 9. How do you compensate for an extra 9? You're going to have to multiply by 1/9. Because the idea is when you take that derivative, how are you going to cancel out that 9? Well, there's going to be a 1/9 already there. How do you cancel out that 5? There's going to be a 1/5 already there. So, our guess was good, except we need a 1/5 and a 1/9. And if you go ahead and put them together, a 1/5 times a 1/9 is a 1/45.
How do we get the x squared?
This x squared?
Yeah.
Because it was the derivative of the inside. The derivative of 3x cubed plus 4, the derivative of 3x cubed was 9x squared. And so,
How we put it in our answer.
well, the x squared was already part of the original problem.
Oh.
So it matches
it's not
up.
even gonna be in the answer.
Right. It's not, our answer is right there with our guess.
Okay.
So we're going to use whatever our guess was. That's our answer, along with any compensation pieces, which in this case was the 1/5 and the 1/9.
Okay.
Okay, so you're always going back and grabbing your guess as your answer. Because at this point, we're knowledgeable enough to know, oh, hey, it was a sine we were integrating. Our answer is some type of cosine. It was something to the 4th we were integrating. Okay, we're going to talk something to the 5th as our answer. We're knowledgeable enough to know that. Does that answer?
Yeah.
Okay, so for an answer, 1/5 times 1/9 means I'm going to have 1/45 times what was my original guess? 3x to the 3rd plus 4 raised to the 5th. And plus c, because it's an indefinite integral. Was that one a little bit better? And that's the idea, is even though these are each different, they should get a little bit better as it goes. They should be more obvious. Okay. Example 3. I think what I would do is before we do a guess, I would rewrite this. Do you know what I mean?
Yeah.
I'm okay with the x squared. What do you know about square root in the denominator? That's a negative 1/2. So I would write this as the x squared, and then it's x cubed plus 1 raised to the negative 1/2 dx. Gosh. My guesses, I'm writing too big on my guesses, aren't I?
Well, it's just a very, confident guess. You just got to throw it out there.
I'm just writing really big, and so it's kind of, I'll have to be better on my next page. This is the last example I'm doing this page, so. Okay. You got a guess?
X to the 3rd plus 1/2.
Okay. The main item we see here, realizing that x squared is going to be part of our chain rule, right? That's going to be part of when you take the derivative of the inside. So don't worry about the x squared. It's something to the negative 1/2. So when we integrate something to the negative 1/2, it's going to be something to the add 1 positive 1/2. So my guess is u equals x cubed plus 1 to the positive 1/2. So derivative of u is du. Derivative of something to the 1/2. Multiply by 1/2 out front. Keep the inside the same, so x squared plus 1. Subtract 1 from the 1/2, and I'm now at negative 1/2.
You lost a cube in there.
What?
You lost a cube.
I did. Why did I do that? Huh.
On the head job.
Yeah, somehow. Thank you.
I think you're solving it.
Gosh. Okay. I probably said the wrong thing too, then is my guess. So, okay, keep the inside the same. I don't know what else I said in there. Just keep the inside the same. You know better. Okay. Times what? The derivative of the inside. I would have figured out my mistake at this point. I would have been really confused. The derivative of x cubed plus 1, 3x squared, and this is all done in x's, so times dx. Okay. Does it all match?
Not all of it.
Of course not.
None of it does.
Okay, so this is where I go back and look. X cubed plus 1 to the negative 1/2. X cubed plus 1 to the negative 1/2. Dx. Dx. X squared. X squared. Okay, what do we need to compensate for?
A 3 and a 1/2.
How do we compensate for a 3? What's going to make a 3 cancel out? A 1/3. How do I compensate for a 1/2?
Multiply by 2.
Multiply by 2, right? And so what factor am I going to put in front of my guess?
2/3.
2 times 1/3. And 2 times 1/3 is 2/3. So I'm going to say 2/3 times my original guess, which was x cubed plus 1 to the 1/2. And then I'm going to say plus c. You could, if you wanted to, go back to square root form. I did in my notes. Okay, was that smoother yet? Okay. Let's try example 4. See how much I can confuse you here. Not trying to, just, this one's a little, maybe you guys can see what's going on. Okay, we're integrating cosine cubed 2t times sine 2t dt. What is the main thing we're trying to integrate?
Cosine third 2t.
Okay, something to the third. Okay. In other words, forget the sign, because that sign is going to be part of my chain rule. Because when you take the derivative of the inside, the derivative of a cosine is going to involve a sign. So just think about it's cosine to the third. So what is the integral of something to the third? Something to the fourth. You see where I'm going with this? Okay. So start with our guess here. It was cosine to the third, so I'm going to say cosine to the fourth 2t. Now, I wondered, you can write it like this, or where else can you write that fourth?
You can put another parentheses there.
You can do a cosine 2t raised to the fourth. Those are equivalent statements, right? Doesn't matter what you do, just if you do this one, you have to have parentheses around the whole cosine 2t as well. Okay, so let's see what our derivative works out. Derivative of u is du. Derivative of something to the fourth. 4 times something to the third. Times the derivative of the inside. What's the derivative of cosine of something?
Negative sign of that.
Negative sine of that something. What is that something I'm talking about?
2t.
2t. Can I take the derivative of 2t? Yeah. So we use the chain rule again. What's the derivative of 2t?
2.
Times 2. And then we're working in t's, so times dt. Watch for that chain rule twice with trig functions like that. If you have anything other than just t or x or whatever variable in there, there's going to be a double chain rule happening. Okay, are you figuring out whatever matches up? Let's see. Cosine cubed 2t. Cosine cubed 2t. Sine 2t. Sine 2t. dt. dt.
So we put 4 divided by 2.
We have a 4. So to compensate and get my 4 to cancel out, I'm going to need a 1/4. We have a 2. What multiplies to get a 2 to cancel out? 1/2. And you didn't overlook it, did you?
Negative.
There's a negative. What will you multiply a negative by to get a negative to cancel out? Another negative. Does that work for you? So I have a 1/4, a 1/2, and a negative, which all multiply together to be negative 1/8 times my guess, which was cosine of 2t raised to the 4th. Because it's, I don't know if it's more proper form or not, but I put my 4 back on the cosine itself rather than outside. And then I'm going to say plus c. That one wasn't horrible, was it?
It's my favorite.
You like some of the others better. Example 5. We are integrating 4 secant squared 3t dt. Okay, so this is where I'm going to say dig deep in your brains.
It's tangent x secant x, right?
No. There's a way we can go wrong here in that what's the integral of secant to the second? We don't want to say secant to the third here. And here's how I know I don't want to say secant to the third, because then eventually I'm going to have to take the derivative of secant, and up above I had a sign. I had something to that was going to happen with the chain rule. I don't have any other trig functions here. So that's my hint that, this might not be the integral of secant to the second is secant to the third. So then you start going through your special integral list, and you start thinking, oh, what's the integral of secant to the second? So what do I take the derivative of and get secant to the second?
Oh, tangent, right?
Tangent. The derivative of tangent is secant squared. Is that, if you dig deep enough, is that in there?
Yes.
Okay. That's, it's on that list. It's one we learned before Christmas. It's just one you have to know. And the more we work with it, the more you'll know it. But, so with that in mind, the integral of secant squared is going to be tangent. So, my guess for the integral of secant squared is going to be tangent of that same piece. So, my guess is tangent of 3t. Is that what your guess is? Okay. Derivative of u is du. What's the derivative of tangent of something?
Secant squared of that something.
Secant squared of that something. So secant squared 3t times the derivative of something. What's the derivative of 3t? 3 times the derivative of t dt. Okay? Well, what do we have going on here?
There's a 3 in the thing, and there's a 4 in that.
So secant squared 3t matches up with secant squared 3t. dt matches up with dt. Okay, so this one has a slight difference, doesn't it? We still have a 3 that didn't match up. And so how do you compensate for a 3? You're going to have a factor of 1/3. Now, why do we always go back and check this?
Because there's a 4 there.
There was a 4 here. It didn't come out, a lot of times those numbers come out in chain rules and stuff. There was no 4 in this problem. And so what you need to remember, when we integrate, keep in mind, technically, you don't have to integrate a constant, do you? That 4 could have been pulled out front. And so what we're going to do is we don't want to compensate for that 4. That 4 is just part of our answer. Because if you're doing the integral of 4 times this integral, then it's going to be 4 times my guess, is what we're saying. So I'm trying to think I just carry this 4 down into your answer. So you're going to have a 4 in your answer. And we also have a 1/3 in my answer. So if you go ahead and put the 4 and the 1/3 together, we're going to have 4/3. So 4/3 times my guess of tangent 3t. And plus c. I wrote it. I wasn't going to say it, but I wrote it. So that's why you always go back and check, did everything from your original problem match up? You don't want to just assume, oh, it all works out somehow. I don't need to go back and double check. That's why I've been double checking every one. Okay. One more, right? We don't have a backside, do we? Nope. We're integrating e to the square root of x dx over square root of x. I would rewrite it just because we don't usually integrate denominators. So it's, which way do I want to write this? E to the square root of x. Square root of x in the denominator is x to the negative 1/2 times dx. Does that work for you? You could flip those two pieces if you prefer, but. Okay. What are we guessing here? I thought I was going to like where you're going, then you stopped. E to the something?
Okay.
Because what?
That x to the 1/2 is being pulled out eventually.
That x to the negative 1/2 is going to be part of our chain rule when we do the derivative of the power. Okay, because what's the derivative or integral of e to the x? E to the x. But when we talk derivatives, the derivative of e to some power is e to that power times the derivative of that power. So realize that x to the negative 1/2 has to do with the chain rule. So, yep. So e to the square root of x, which I guess in my notes I changed it to e to the x to the 1/2. That probably makes sense, doesn't it? Yeah, I don't know why whatever. Now that we actually have to take the derivative, it all of a sudden dawned on me, oh, I probably should have said e to the x to the 1/2. So you could have done the same thing here, right? That is x to the 1/2 if you prefer. Okay, so derivative of u is du. Derivative of e to some power is e to that power times the derivative of that power. What's the derivative of x to the 1/2? 1/2 x to the negative 1/2 times dx. Okay. Have you checked? Let's see. E to the x to the 1/2. E to the x to the 1/2. X to the negative 1/2. X to the negative 1/2. Dx, dx. What has to go in your answer? A 2, because we're compensating for the 1/2. Okay. What's your answer then? Okay. 2e to the square root of x plus c, or 2e to the x to the 1/2. I don't care. you guys know their equivalent. That's the key thing there. Okay, we're pros now?
Hopefully, we'll find out soon.
Where's
We're gonna
that
get to the
degree?
homework, and it's gonna be like,